Namaskar. It gives me immense pleasure to introduce you to the Indian Plumbing Association's Plumb Talk series. As part of Plumb Talk, plumbing industry experts from across the country will be explaining the nuances of plumbing technology in an easy and understandable manner. And this will make plumbing science easier for building industry professionals, engineering and architectural students, as well as the general public to understand the basics of plumbing technology. Let me give you a little background on IPA, which is the apex body of plumbing professionals in India. IPA is now a 29-year-old body started in 1993, currently has 24 chapters working towards redefining plumbing standards in India, tirelessly working towards better plumbing for a healthy living. I therefore request you to please go through the Plum Talk series, which will be a guide for students, for architectural students, for even current architects and engineers, so that you are able to improve your knowledge on plumbing and ensure that all plumbing installations are installed not only as per codes, but we make sure that whatever water we use, we move towards net zero water and net zero sanitary waste.
Namaste. I am Nilesh Gandhi, Chairman of Indian Plumbing Association Pune chapter. I am also on the national level technical committee member. It gives me immense pleasure to welcome you all for the Plum Talk, a wonderful initiative of IPA under Center of Excellence. I will be sharing my views and experience on stormwater drainage system and rainwater harvesting. This is covered under Chapter 6 of AGGP, a guide to good plumbing. I am happy to share that AGGP, which is a solo publication of IPA, has been published in 7 regional languages. This is to promote knowledge in a better way. Now let's see the design of stormwater system in more details. To understand the stormwater drainage system, we will review few terminologies like catchment area, rainfall intensity, runoff coefficient, time of concentration, return period of storm, intensity, duration, frequency curves. All areas during rainfall which will contribute are called as a catchment area. Rainfall intensity is the peak rainfall per hour expressed as mm per hour or centimeter per hour, and which is used for design of stormwater drainage. Local IMD will give you the basic data based on which you will have to derive this information. Runoff coefficient is the indication of imperviousness of the surface. That means whatever water a surface can retain or drained off expressed as a percentage. Higher the runoff value means more the percentage. Time of concentration is the time required for rainwater from the farthest area of the catchment to reach the stormwater outlet. Return period or design storm frequency. It is the average number of years between occurrence of a storm of given intensity. Intensity duration curves are the curves used for working of specific rainfall intensity for your given time of concentration. The curve for given frequency or the return period is a plot of several storms of varying length, not on a single storm plotted against time. These curves are very helpful in getting accurate design rainfall for your specific project time of concentration, and the design becomes more economical and correct. Stormwater drainage system provides means of conveying rainwater from road, building, open plots into public storm network. The code regulates the design, construction, installation and quality of material used for drainage system in order to protect the public health. Material for stormwater drainage piping used in India is predominantly RCC hume pipe, RCC or brickwork trenches. Very few projects use HDPE or DWC pipe or a rigid PVC pipe for external water drainage. Building code requires roof drainage water not to be permitted to flow over the public property or the side walkway and walkways. Roof drainage is also required for all building to prevent collapse of roof due to extra load of water on the structural slab. Where a plug drain could allow rainwater built up on a roof, a separate emergency overflow shall be provided. In single or dual family dwellings, it may discharge on a flat area to drain away from the building and adjoining property and shall not create a much nuisance because quantum is very small. Stormwater shall not be drained into sewer intended for sanitary drainage only, as it may disrupt the function of sewage treatment plant. All roofs, paved areas, yard, courtyard shall be drained into separate storm network or into a combined sewer network if accepted by the authorities. Presently in India, separate sewage and stormwater network is mandatory. There are two types of roof drainage system. One, gravity rainwater system. Second, siphonic rainwater system. Gravity roof drains relies on the height or the depth of water over the surface or gutter. The head operating gravity rainwater system is very small, so the design or the size of pipe is bigger in dia. The size of rainwater pipe also depends upon the rainfall intensity and the catchment area which a pipe is catering. This is exactly what happens when a rainfall falls onto a roof and flows into gutter. The depth of water accumulated over the gutter is a driving force for rainwater pipe diameter. The depth of water accumulated in the gutter is the driving force which causes rainwater to flow towards the roof outlet. As we have some better depth in gutter as compared to the depth of water on the flat terrace, the performance of gutter system is better. Primary and secondary roof drains are the two main components of the gravity system. We have already seen the primary system. Now, why a secondary system is required? I am sure in India you have not seen a secondary system actually in existence.
Yes, you are right.
Though it is not a mandate today in India, but outside India, secondary system is mandatory. The reason we have already seen. If you have a flat RCC slab and a parapet adjoining to it, then it can act like a swimming tank. And if for some reason your primary system fails, then the secondary system has to be activated. Otherwise, there will be loading of water on the top terrace and structurally the slab can fail or water can drain from the staircase into the floors below. The discharge of the secondary or emergency rainwater drain system shall be above grade in a location observable by the building occupant or maintenance person. Secondary roof drain system shall be sized in accordance with the code based on the rainfall rate for which the primary system has been sized. Type of gravity based rainwater pipe outlet are made of cast iron, aluminium, stainless steel, polyethylene, copper or copper alloy. Approved polymer is also used for the outlet. We have seen that primary and secondary drain outlets are different, but we can also have an engineering design outlet wherein the primary and secondary can be fitted into one outlet only. An alternative sizing method for stormwater drain. It utilizes the pre-calibrated weir on the roof drain to control the flow. This works as a primary come secondary outlet. Whenever the primary outlet is clogged, the water will overflow from the top and a secondary outlet will be operated through the same outlet. For designing of stormwater system, we will have to see the following formulas. The discharge is calculated as Q is equal to CIA upon 360. This is a rational formula wherein C is coefficient of runoff, which is unitless, I is rainfall intensity in mm per hour, A is the surface area in hectare, and you will get Q in m cube per second. The velocity of flow for a circular pipe is calculated with the help of Manning's formula. V is equal to 1 upon n into r raised to 2/3 into s raised to 1/2, wherein n, which is the Manning's coefficient for RCC surface, which is 0.015, r is the hydraulic radius and s is the slope. The calculated actual velocity for the pipe flow should be between 0.7 to 3 meter per second. We have seen the gravity system. Now we will go into details of siphonic system. Friend, this is a relatively new project or new system for us, but in Europe and US this type of system has been used for longer duration, at least 30 to 35 years. Unlike traditional roof drain system in which pipe is flowing partial, siphonic system operates on the full flow of the pipe. That means the cross section of the pipe is full. This happens because instead of a head used in the gutter in gravity system, siphonic system uses the full building height as a head for its working. It siphons from the roof downtake into the drain at high velocity. A conventional outlet is simply a hole in the form of outlet, but a siphonic outlet has anti-vortex plate which prevents air going into the system, resulting into the full flow. It is based on Bernoulli's principle, and as mentioned earlier, it utilizes the full static head of the building. The siphonic full flow system allows architect, consultant and contractor to utilize lesser number of roof outlet and significantly low number of downtakes also. Different stages in siphonic system are gravity flow, like we have designed the system say for 100 mm per hour. Every day you will not have 100 mm per hour rainfall intensity. So typically it will start somewhere between 15 to 20 mm per hour. In that duration, the siphonic system will also act as a gravity system. That means typically between 10 to 30% of design flow, the siphonic system behaves as a gravity system only, and the pipes are partially filled. Flow pattern 2 is a plug flow. As the stormwater intensifies, the water above the siphonic outlet will increase intermittently. When the water level increases, the wear entrance in the piping system will stop and a plug or the cylinder of water will enter into the pipe, followed by the gap with the air. This keeps on happening. At the interface where the fast moving water meets slow moving water within the pipe, a plug is formed. The action of the plug of water falling within the downpipe provides initial siphonic action. The third pattern is a bubble flow. Eventually, when the stormwater intensify to substantial or to the highest level for the design intensity, the water will start entering into the system, moving at such a rate that the individual plug of water meet forming more or less continuous flow, but with air bubbles in the evidence that the system has still not reached the penultimate state. Last, or the full bore system, is when the design storm has reached its maximum intensity for which the system has been designed, and the pipe will run full of water. Once the intense part of the rain has dissipated, the flow pattern within the pipe work will return again from 4, 3, 2, 1. It is very essential to have a siphonic drainage system designed from a company specialized in this technology. Siphonic outlet is one of the important part of a total engineering solution offered by the manufacturer. A siphonic drainage engineer must be aware of the hydraulic and the behavior of water under different conditions. He should be qualified in solving relevant problems pertaining to fluid mechanics. High-end software is used to design siphonic drainage for draining most complex roof. A system designer is fully qualified to provide full design service. Large number of domestic and international projects has been successfully designed and executed, offering cost-effective solution in draining the most complex roof. Success of a well-designed system is meaningless without proper installation and support. Advantages of siphonic system over gravity system are immense, like siphonic rainwater discharge system are more modern and it will reduce the number of downtake to almost 50%. The horizontal header do not require any slope. The downpipe can be located at the convenience of the architect. It also reduces the cost of aesthetical camouflaging of downtake in case of gravity system which are more in number. Siphonic system is more efficient since the water is flowing full. Not only the downtake but the pipe size in diameter is also reduced. The system uses full static head from gutter to the first drainage connection. You can see a arrangement showing gravity and siphonic system in the same video. The siphonic pipe size is small. The gravity pipe size is almost double the siphonic. In the tank, both siphonic and gravity outlets are subjected to same flow rate. You can clearly see that siphonic pipe is running without any slope as against gravity pipe is running to the slope. The water in the cross section of gravity pipe is 50 to 60%, as in siphonic it is almost full of water. When the pipe is connected to the last chamber, the siphonic pipe is also converted to 2 times the diameter to connect to the gravity connection in the end. This video clearly explains you that in siphonic system we can reduce the pipe diameter, we don't require a slope, and the same flow rate is been taken care. This is a very good demonstration which can explain much better than 1,000 words regarding siphonic. For designing of the ceiling suspended rainwater horizontal pipe, we use the chart shown on the video. This is from the BS code, wherein different pipe diameter with different slopes has been indicated and the flow carrying capacity of all those has also been shown. This is the standard table from National Building Code 2016, which shows the load carrying capacity of different diameter from varying rainfall intensities. It is given in the form of meter square of catchment area. It is different for CI/DI pipe and PVC pipe. PVC pipe can carry almost 44% extra load as compared to CI/DI pipe because of the smoothness coefficient. Now we will go to another drain system called as a subsoil drainage system. Subsoil drain shall be provided along the perimeter of building having basement or the cellar. A perforated pipe of minimum 150 mm diameter wrapped with geotextile membrane is recommended. This pipe is backfilled with a free draining material like coarse murum, aggregate or coarse sand. This pipe network is connected to public stormwater system either by pumping or by gravity if the invert level of public stormwater drainage permits. In case of pumping system, the sum shall be sized as per the flow from the subsoil water per day. Pump shall be minimum one working, one standby, and they should operate on the level sensor. The recommended solid handling capacity is minimum 20 mm. Here we completed the stormwater system. Now we will review the rainwater harvesting system, which is also an important aspect. In principle, rainwater harvesting consists of intercepting rainfall wherever it occurs, saving that water in various storage structure which can be either natural or man-made. We shall try to percolate the balanced water to maximum extent in ground to raise the water table level. In short, prevention of losses through evaporation and beneficially using stored water locally. In a universe, life is known to exist nowhere except Earth, and the main reason is water. Modern science unequivocally believes that life cannot exist without water. Life has sustained on Earth for more than 3.5 billion years because of some of the extraordinary attributes of Earth, and one such attribute is the hydrological cycle, by which a small fraction of 1% of all fresh water on Earth is circulated over and over again. One part of rain falling on land flows in rivers and stream towards the ocean, and one part of it goes back to atmosphere as evaporation and a transpiration by plant. The remaining part circulates underground as subsoil water and groundwater. It is within this simple and yet profound framework rainwater harvesting needs to be understood. So friends, now you have realized that we have very narrow margin. To understand the importance of rainwater harvesting, we all know the contributor to that are growing population, modernization and industrialization having its ill effect, global warming, abnormal changes in hydrological cycle, growing differences between the availability and the requirement of water globally, acute shortage of fresh potable water. To recharge the underground aquifer for sustainability of the water table at lower depth, and it can be further reused for human need. Friends, you will be surprised to know that places like Cherrapunji in Assam, which receives 11 meter of rainfall per year, also suffer from the acute shortage of water during summer. This is because of the topography, all the water gets drained into the valley. Now, if we would have provided some water harvesting structures there, we would have saved some water or stored some water and could have used for the summer purpose. This has also resulted in over exploitation of surface sources like well and borewell, which has lowered the water table level in the surrounding area. Now we will see how we can harvest the rainwater broadly in two ways. One is surface runoff harvesting, second is rooftop rainwater harvesting. Any water harvesting system will typically have following four elements: catchment area, conduit, first flush, settlement tank, recharge facility. Catchment area is any area or the surface which will receive rainfall directly. It can be surface such as paved or terraces, courtyard or the building, lawn or upper ground. In fact, temporary structures like sloping shades can also act as a catchment area. Runoff factor determines the quantity of water which will be available from the catchment. Runoff factor for woody or grassland varies from 10 to 30%. That means rest of the water is percolated, whereas runoff factor or paved or terrace area can be between 70 to 90%. As most of the rainwater is available for recharge or storage except for water loss due to evaporation. Conduit are the pipe which carries rainwater from catchment or the roof top to the harvesting structure. The conduit can be of PVC, HDPE, GI pipe or locally available material. When you have terraces, the dust and the dirt which is present on the terrace needs to be flushed. First flush is a device used to flush water received in flush shower. The first shower need to be flushed off to avoid contamination at atmospheric and catchment roof level. It will also help cleaning the silt and other material deposited on the roof like bird dropping during dry season. Settlement tank is nothing but a storage tank which will collect all the rainwater from the downtake and it will allow dirt to settle in the tank. The overflow of the settlement tank will be connected for the further storage purpose. If you want to use this water for specific uses, then based on the use, the treatment has to be offered. This water can be easily used without much treatment for gardening, for flushing, etc. As volume of water generated by rainwater harvesting is very large, it becomes uneconomical to store all the water in tank. Then we shall try to percolate this extra water in the nearby aquifer by connecting harvested tank to dry borewell or existing well. A typical arrangement of recharge is shown in the drawing below. There is a major difference between methods adopted for rainwater harvesting in city and village area. The city area we have lot of hard surfaces, paved pathways and we get a good quantity of reasonable pure water from the collection. But problem in city area is costly space for storage. So we store bare minimum and try to percolate the maximum water to underground aquifer. In case of village area, we do not have much of water from paved or the terrace area, but we have majority of quantity water from the surface area. So we do contour terracing of land and rainwater is held at intermediate interval for percolation. Finally, it is diverted to deep well pond. Advantage of rainwater harvesting are we will get water for direct human consumption, which is not possible by using any other machine. We cannot generate water artificially on such large scale. So, rainwater harvesting is the best way one can capture large volume of water. Hot and arid places like Rajasthan in India, where there is a huge scarcity of water, whatever rain falls in desert is absorbed in soil or evaporates. In such places, rainwater harvesting in the form of storage is a boon. Rainwater harvesting provided self-sufficiency of water supply. Now, let us discuss the disadvantages. If we are having a large industrial roof of fertilizer company and we try to do the rainwater harvesting, then the chemicals on the roof will also get mixed along with the rainwater and it will have ill effect on the groundwater which is stored. If the catchment area is polluted biologically, then there will be issues of borewell in that area. For example, if we do not have a sewerage network system and the overflow of septic tank is connected to recharge pit, then the borewell in that area will have biological contamination. By drinking that water without treatment will lead to diseases like cholera and malaria. So friends, we have to be careful while doing a rainwater harvesting. Also, if you are very close to river, then rainwater harvesting in a sense does not make much advantage, as that water in no time will get connected to river. This is construction technology used for rainwater harvesting pit in a ready-made boxes. You can see PVC or HDPE chambers are used to convey stormwater to a HDPE container connected in the form of a jigsaw puzzle boxes. These HDPE boxes are prefabricated and they can be connected with each other very easily. In the drawing, you can observe that rainwater can get percolated into these boxes after getting filtered into geotextile membrane. These are few of the construction slides which will help you understand. They have done the excavation and done the leveling. After that, they have laid the geotextile and the HDPE lining. On top of that, these HDPE boxes has been assembled and they are completely sealed with a HDPE liner and geotextile again. The inlet and the outlet connections are also well taken care of. This slide shows the storage of rainwater for the secondary use. After the work is completed, the top is backfilled with a soil and later on you can do the paving on top of that. The structure can take easily the load of car parking. These are few indicative figures showing connection of cleaning shaft with the pipe and with the connecting HDPE boxes. These are few more figures showing different sizes and shapes of the boxes. Now let us see the modern technologies used for rainwater harvesting. Permeable concrete is one of such technology. Resin bonded permeable concrete is a technology which makes concrete to allow water percolation starting from 30 inch per hour to as high as 300 inch per hour per meter square. Pervious concrete is also known as no fines or porous concrete. It is very environmentally friendly solution for stormwater management. The density is around 1900 to 2000 kg per m cube, porosity varying from 15 to 20% and a 7 days compressive strength of 12 MPa. This concrete provides a smooth, attractive, UV stabilized, hard wearing surfaces. These are most suitable for applications like patio, pathway, courtyard, parking lot, etc. Super pervious with a flow rate up to 10 times the grass paver and pervious concrete is also available and it is best suited for counter solution as an alarming urban problem. Aesthetically pleasing, high durable, UV stable, hard wearing surfaces unaffected by salt, oil spills and ultraviolet rays. Pervious concrete will not fade in color or deteriorate with severe weather changes. Pervious concrete system provide a slip and skid resistant surface. No loose stone, restricted weed, algae growth, superb range of aggregate blend. We can use the system above podium, non-pervious base. So friends, you must have understood now how important it is to manage your stormwater system in a most efficient way. And going further, rainwater harvesting is going to be a leading factor for saving of water. We will have to utilize rainwater harvesting water in a most efficient way as described in the video. I would like to thank IPA for giving me this opportunity. We request you to watch more such videos on a guide to good plumbing practices on YouTube channel of IPA. This is Nilesh Gandhi signing off for today, and if you like the video, then please subscribe and share with your friend, and also press the like button. Thank you.